Hi, I'm Paul Battaglia, and this is section 8.3. See, students come into section 8.3 with a little knowledge of the nth term test. So they've looked at one test and they've now seen geometric series as well. Now remember, they also have knowledge of how to work with an improper integral, and that's going to help them in this section as we look at the integral test. So the essential question we would like students to be able to answer at the end of section 8.3 is, what other tests might I use to determine the convergence or divergence of a series? Now let's specifically look at the first four examples in the text. I love them because they're all good, but all for different reasons. So example 1's great because it actually helps us address mathematical practice number 3C. Confirm whether hypotheses or conditions of a selected definition, theorem, or test have been satisfied. See, students need to understand that if we're going to try and use the integral test, that we must be looking at a function that's positive, continuous, and decreasing. And many times that's a common mistake. Students actually just assume that they can use the integral test on any function. So challenge them to think about that a little deeper and make sure that they're making the right choice and they're recognizing the correct time to use it. Now example 2 actually is just one that I like because students actually might have to look at a little bit more the arctangent function. See, throughout that integral and using an improper integral in that process, students are going to have to evaluate the inverse tangent function. So they might forget some of those values. Remind them of A, the graph, but B, also their knowledge of the unit circle. That might help them as well. Example 3 might be my favorite because it allows us to extend what we show and maybe use some discovery here. What I would actually do is I would present students with the integral from 1 to infinity of dx over x to the p power. And what I want them to do is run through the integral test 3 times. Once for p is equal to 1, one for p being greater than 1, and one using a value of p that's between 0 and 1. Now I wouldn't specify for them what to use other than p equals 1. So if they'd like to use p equals 1/4 and p equals 7 over 2, that's their call. But I think as they go through those 3 examples, they can see how a p-series comes to life and what's required for a p-series to converge versus diverge. Lastly, example 4 is a fantastic example because it actually makes students see that when we use summation notation, we don't always go from n equals 1 as the lower limit to infinity. Here we have to use n equals 2 because of a restriction on the domain. See, the way it's presented, ln of n is actually in the denominator of a fraction. So therefore, n cannot equal 1. It'd be restricted. Now, here are 2 big mistakes that students make in section 8.3. I actually alluded to one earlier. It's the idea that they think they can use the integral test whenever they see a function. And actually, my students have told me, as they've gained more experience, that they actually use the integral test as a test of last resort. Now, it's early yet, and your students have a lot of tests they still have to learn, but see if that holds true for your class as well. Also, remember, now students have now discovered what a p-series is and when a p-series converges. And they might actually confuse this with a geometric series. So let's kind of clear that up. For a geometric series, we're looking for the absolute value of the common ratio to be less than 1. And if so, that geometric series converges. For a p-series, we actually need the value of p to be greater than 1. And that's what allows it to converge. So watch for that mistake as well. Now, finally, students have to be ready to kind of extend the concept a little bit and view these questions in different lights, particularly on the AP exam. So don't be surprised if we ask students, and feel free to ask students, okay, so I'll give you 1 over x to the p minus 3. What value of p, or what values of p are necessary to make this series converge? This gets them really thinking a little bit outside of the normal rules into what they're really looking for and what they're looking at. The more you do this for your students as we get into some of these tests, the better it's going to be for them. Helps them recognize, gives them a little bit more confidence, and it really gets them ready to look at some other things, maybe some more complex things. I hope you found these tips helpful, and I'm sure you'll find much success in section 8.3.